Good morning, AP Calculus students. New topic here, and that is L'Hopital's rule. It's a rule that helps us find the limits of certain functions that, after direct substitution, take on the indeterminate form. And I'll show you what I mean by that. Let's get right to the slides. So, L'Hopital's rule, we're in Chapter 8, and let's do a quick recall of what we did back a long time ago in the limits chapter. Remember, the limit is some number that's approached by some function as we approach a certain x value from both sides. And we did that a couple different ways. We made a table, we plotted them on our calculator and looked at the calculator. And then we did a lot of techniques involving algebra that are called the analytical methods, direct substitution, dividing out, rationalizing, special trig functions. And recall, when we put 1 in here, we got 0 over 0, and that's an indeterminate form. We don't know what that means. Recall when we first did this a long time ago, we just factored the numerator and then reapplied direct substitution, we got an answer of 2. But what L'Hopital, a French mathematician, discovered that is that if you take the derivative of both the numerator and the denominator, derivative of the numerator is 2x, and the derivative of the denominator is 1, and then you apply the limit with direct substitution, you'll get 2, and you'll see that you get the same answer that we got using the dividing out technique. And so he's famous for this technique, L'Hopital is, among other things. This special trig function, remember I had you guys memorize this a long time ago. This also gives us 0 over 0 with direct substitution, but if I take the derivative of sine, I get cosine, and the derivative of x is 1. And then if I take the limit as x approaches 0, if I stick 0 in here for x, the cosine of 0 is 1. And sure enough, L'Hopital's rule works even for the special trig function. So let's apply his rule in a few other instances. His rule is really handy when you really can't divide out, like if you have e's or natural logs, and so these will take that form. And so look out for that on tests and on the AP test. It's probably a big clue that you're going to need L'Hopital's rule. And this is on the AP test, by the way. If we put 0 up here, we get 1 minus 1, which is 0 over 0. If I take the derivative of e to the 2x, derivative of 1 is 0. Derivative of x is 1. Now I do direct substitution. Anything to the 0 power is 1, and so this becomes 2. And so look how easy it is to find the limit, which otherwise would be rather difficult for us to do. Let's take a look at another one. If I put infinity in here into the natural log function, well, that would be very big, infinity. And infinity into x is infinity. So we have the indeterminate form, infinity over infinity. So let's take the derivative of the numerator and the derivative of the denominator. Now if I put infinity in here into 1 over x, I just get 0. And so, again, very powerful technique, very quick. In this particular example, we'll see that we'll need to use L'Hopital's rule twice. Let me show you what I mean. If I put negative infinity here and square it, I'll get infinity. If I put negative infinity here, I'll get e to the infinity, which is infinity. So I have the indeterminate form infinity over infinity. So I take the derivative. And now I plug negative infinity in here and I get negative infinity. And a negative infinity into here would give me negative infinity. And so that's also indeterminate. And so let's take the derivative again. And now we're finally getting somewhere, because when we put negative infinity in here, we get e to the positive infinity, which is a really big number, and any number over a really big number is 0. And so watch out for cases where L'Hopital's rule doesn't work after the first derivative, but the second derivative, it does work. And finally, watch out for problems that look like this. This looks like negative infinity times infinity, which is not an indeterminate form. But if we rewrite this as square root of x all over e to the x, and then if we put infinity in here, we get infinity over infinity. That is an indeterminate form. So we'll take the derivative of the numerator and the derivative of the denominator. And now when we plug infinity in here, well, let's simplify this to show you that this is e to the x and then square root of x. And so we're going to get a very big number down here when we plug infinity in and 1 in the numerator. And so this just becomes 0 as well. And so those are several examples of L'Hopital's rule. I hope that that was enlightening, and sorry for the length of this video. It's the last video before Easter. Have a happy Easter, and if you don't celebrate that holiday, a nice weekend and a safe weekend, and I'll see you next week. Bye.